In previous lecture, we have seen about the entropy. Now, in this lecture, we have to gain some knowledge about the entropy. So let's see. Actually, here we will learn about the knowledge of information scale. This is the very important concept in the chapter in the subject of mainly information theory. So let's see how this information's gain will work. So for understanding, I am taking their data sets is like that. That also we will see this data set already in previous lecture. We have already seen this data set in previous lecture. So suppose let's take this is the data sets D. Okay, and these data sets we have four features: outlook, temperature, humidity, and ONT. Just I am taking this data from the Google image. You will just search on Google play tennis data. Search on Google play tennis data. On Google, just then go to the image section, then you can easily find this data set. Okay, there in this data set we have four features: outlook, temperature, humidity, and wind. And corresponding, this is the features 1, features 2, this is features 3, and this is features 4, and corresponding output yi is play tennis, yes or no. Okay, this is the features, and in this data we have 14. The number of points in D is equals to here 14. Just see 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So total we have 14 number of points in this data set. And the output is here, output will be either yes, it means, or no, either yes or no, or output. And we call yes is y plus and no is y minus. Simple. I am labeling this thing. Okay, now we are divided our data in three partitions. We are dividing our data in three partitions. So this partitions is, first partition is called the D1, this partitions is D1, this is D2, and this is D3. We are dividing our whole data set in three partitions: D1, D2, D3. In such a way, we are dividing our whole data in by the first features, only by using the first features. Just for an example, this is our example. This is the features 1. By using these features, we will divide this whole data. This is example the features 1 data. Okay, we will divide it all the data. So how many category in this features 1 outlook? Just see the outlook. There have three features: sunny, overcast, and rainy. These three features, these three category only have for outlook features. So we have for outlook features, we have three categories. So first is sunny, second one is overcast, and third one is rainy. Okay, so now we have divided our whole data sets by using the features 1 according to their each category. So first see for sunny category how much point we have. So sunny, just see this. So just I am using here blue ink for denoted this red ink for denoted the sunny. So this is sunny 1 2 3 4 5 4 5 5, this one. This total 5 data we have for only for sunny category. So just I am collecting this data. Sunny, then weather is corresponding weather, humidity, and winding corresponding output. Okay, just this way we have writing. So we have see already when we are constructing the decision tree, then we have see we have building our data set like that. This is our parent data, corresponding that we have built. This is one features, this is another features, this is another features, corresponding that we already built. But instead of taken vertically, I am using this category as horizontally. Okay, this thing I am taking here. So just this partition, first partitions for category sunny is called the first partition is called the D1 partition, second for category overcast is called the D2 partitions, and third category rainy is called the D3 partitions. D3 partitions we rename it, and our OII, here, our OII is either Y plus, that is yes, or either Y minus, this or no. Okay, this thing happen here. So, and already we have seen what is the entropy. What is the entropy for this data set? We in previous lecture already we have seen the entropy of this data set is H of D, means D is this data set is D, this is D1, this is D2, and this is D3. And the entropy for the whole data sets, data sets, for the output, for this output, for this point, for this means we are interested to calculating for this output variable y, which we have already seen. This output is 0.94. if you forget, please go there, just go the previous lecture, and you can easily see this entropy value is 0.94. Now we have calculated the entropy for the each partitions. Let's see. And one thing we just remember it, how we will calculate it. If you just forget, I remember you just how we'll calculate it. Our formula is here k is equals to what? Because of these two features, our here k is equals to 2, so our I will be 1 to 2 minus log 9 minus what? Minus probability of y is equals to y I. So I means here y plus or minus, and the log of probability of y is equals to yi. Here we have two class only, yes or no, means y1 if you call it, and if you call it y2, just call it. So this value will be minus how much yes we have here? 1 2 3 1 2 3 4 5 6 7 8 9, total 9 years. Here we have total 9 years, and out of 14 into how much? Log of 9 by 14 minus we have how much? 5 by 14, no, log of 5 by 14. So if you calculated it, how will value we get? This value 0.94. this value we will get. Just we will see this thing in previous lecture. Now we will calculate the entropy for each data. So what will be the entropy here? Entropy for the D1, here entropy for, see here, so for this data set, for this D1 data set, sample D2 data set, this is the sample D3 data set. Now what is the entropy of the data set D1 corresponding to the variable y? What will be this? This value will be how much? Yes, we have here, yes we have 2, and no we have 3, we have no 3. So this value will be just calculated minus out of 5, total number of data for this partitions is 5, so yes is 2 by 5 minus log of 2 by 5 minus no is 3 by 5 minus log of 3 by 5. If you calculate it through calculator, you can easily find this value is 0.97. Similarly, for this data we can easily calculate it. E of D2 of y, this value will be 0, because why? Here all the value is yes, so here 5 out of 5 is yes, 5 out of 5 is yes, corresponding log of 1, minus 0 out of 5 is no, corresponding log of 0. So this value will be 0. Similarly for this, also d of, you can calculate it easily. Just same thing also happen here, because in these cases we have 3 no's, in these cases we have 3 yes, but because of this we have easily calculated. We can, the same calculation will be occur for this case also. So this value also will be 0.97. Okay, just see this. Just see these calculations. Each partition. Okay, I think you will understand this value, how it is calculated. Okay. Now the informations gain. Now the definitions of informations gain for these features, for this particular features, first features, that is outlook. Now the definition, see the definitions of the information. So the informations gain for the variable y, for the variable y, information scale for the variable y, for the variable y, with features what? With the features outlook is will be the what? Actually these features will be the parent features. What? It is the parent data and it is the child data. In another language we call this data is the parent data. This data is called the parent data. And this data, this age data is called the child data. This data is called the child data of D. Child data of D. Okay, so the informations, now the definitions of the informations get for a corresponding features outlook, which means this features is F1, is the entropy of the parent features for the variable y minus the entropy of the child features for the variable y, corresponding to same or corresponding to the same features. Corresponding to the same features means, okay, no problem, corresponding to the same variable, okay, y, because this actually this entropy, this child is produced through this entropy. This child is produced through these features, okay, because from these features this child is produced. Just this is the simple formula of the information scale. So what is the entropy for the parent, for the parent? Just see the parent, for the parent entropy, here we have seen the parent the parent entropy is 0.94. And what is the child entropy? Child entropy is this one, 0.97, 0.97. Now one thing we have to remember, here we have to weight it, how much weighted we have to give for each child. Here child is 3, d1, d2, d3. Just see this thing, here we have 3 childs, here we have 3 childs, d1 child, d2 child and d3 child. We have 3 childs. Just see in the first child, just d1 child, if you see how much point we have here, in this point we have 5. We have total image, total we have 5 points. Here we how much point we have, here we have total 4 points. Here we how much point we have, total 5 points. Okay, so total, so what will be the probability of, what will be the probability for occurrence d1 from the whole data sets? This probability will be 1 by total. How many points for the whole data set? So number of points for the whole data set is 14. I think it will be 14. Total how many points? Total we have 14 points. Here how many probability will be? Here the probability of D2 is how much? 4 by 14. Here what will be the probability? Probability of the D3 will be 5 by 14. This is the simple weighted value for each child. Okay, for the first child this would be weighted. I will give this amount of informations for the child one. I will give this amount of information, this amount of importance for this child 2. I will give this amount of importance for the child 3. So this is simple the weighted value for each child. Okay, this is simple weighted value. Now the entropy of the entropy of the child will be calculated like that. So first weighted value is what? First weighted value is, I think, 5 by 14. So the first weighted value is 5 by 14. into its corresponding entropy value, means 0.97. 0.97 plus what is the weighted value for the child to 4 by 14 and corresponding entropy plus 5 by 14 weighted value by corresponding entropy, means what? 0.97. 0.97. Okay, this is simple. Just if this thing is actually called these things is actually called the weighted entropy of the child's D1, D2 and D3. This thing is called the weighted entropy. And if you just calculated this thing, so how much point, how many, if you just calculated this thing, what will be the value? This thing, what will be the value? Just to see this thing, just calculated it. 0.94 into 2 into 5 by 14 into 0.97 plus 0. So what will be the value here? 7. So this value will be 5 by 7 into 0. Just calculate it in yourselves. Just I am not calculating here. Just calculate it in yourself. This will be this will simple the call the information gained. This will call the sample the information. This will simple call the information's gain tens of y corresponding to the features f1 corresponding to the features s1. This is simple the formula, the information scale. Okay, I think you have understand this thing. Now just write down its general formula. So what we will see here, just first see this thing pictorially, then then we have a first data. This is called the D, means this is the parent data. Actually this data actually called the parent data, and corresponding the S data we have divided this data in 3 portions corresponding according to the features 1. According to the features 1 we have divided this data in 3 portions, D1, D2, D3. This thing is called the child node. This is the parent node. This thing is called the child node. Okay. Now what will be the simple formula of information's gain for a variable y and corresponding to features 1 is equals to, these features will be summation of this feature will be entropy of the parent node for the variable y minus the number of point of the child node D1 divided by total number of point of the parent node into corresponding entropy h. I think corresponding entropy h. Just I am denoting here h. Just omit this thing. Just neglect this thing. Here entropy for symbol h I am using here. Just I have using here h. Don't be confused h and e. Just I am using the symbol h instead of e. So these are depend on author to author. Just h I am denoting here. Just don't be confused e and this. Just I am instead of entropy e I am using here h. So h of d1 variable y plus Similarly for d2 into h of d2 corresponding to the variable y plus this is the simple formula of this example. This is the general formula of this example, of these examples. And how we will divided these node d1, d2, d3 according to this feature. According to these features f1, we are dividing this node d1 to d3. Okay, this is the simple formula. Now let's see, let's write down its general formula. Suppose let's take, we have a random variable d and its category for this random variable is, suppose let's take k category. We have h y1 y2 y3 up to yk. Let's, we have category and it's the parent node d for this random variable, and for y1 this child node d1, this child node d2, this child node d3, this child node dk. Then what will be the information gain actually if for the random variable y corresponding, suppose let's take corresponding a variable I'm just taking here corresponding a variable var. Okay, so this formula will be first h of entropy of the parent node minus summations of the I is equals to what, I is equals to 1 to k of the weighted means d of yi by norm of t into its entropy value. Okay, I think you have understand this thing. This is the simple general formula of the information. Okay, I think the geometrical concept from this example, the geometrical concept is clear. This means what actually? If you just languagely, if you just read this thing, informations gain, what we will get, this amount we will get here. If you just read this thing in languagically, this means what? Actually, from these features f1, we get this amount of informations from this only from this features f1 for this output level for this variable y, we get this amount of information, that is we have gain here. This means that nothing else. This is the simple English meaning of this information span. This, if we calculated this thing numerically from this formula, from this formula we have calculated by simple using this formula. If you just read this thing in English, then from this features outlook, for this features outlook of this variable play tennis, we have gained this amount of informations of the whole data. Okay, I think the geometrical perspective as well as how this formula comes into the picture, you will understand, you have understand already. Okay,